All right, so we're back talking about more complicated expression involving division and negative exponents. This one certainly has escalated very quickly. We've got a positive exponent on the outside of the top part of the fraction. We've got a negative exponent nested on the bottom. Bottom line is you have to deal with the exponents first. All right, since it comes before division and multiplication in the order of operations, you have to talk about, hey, I need to distribute that 3 to all parts of the top. We did that yesterday, and there's no real difference. The idea is I multiply the outside power times the inside power. And then I apply that power to the new one. So this is going to be n to the 15, m to the negative 6, and 3 times itself 3 times. So here's what that looks like. 3 times 3 times 3. M to the negative 6 and n to the 15. Now I'm going to do the same thing on the bottom. It's going to be kind of tricky though with this negative exponent being applied to a coefficient. Now a lot of people think that 5 to the negative 1 is just negative 5 right off the bat, but that's not true at all. 5 to the negative 1 is the same as it's just in the wrong spot in the fraction. So it's like 5 to the negative 1 is the same as 1/5 to the first power. Yeah. So we're really looking at 1/5 when we distribute that negative 1 to it. My advice is just to put the negative 1 exponent with the 5, and then we'll deal with it with the other negative exponents. Here's what I mean. So n's going to be to the negative 3rd power. M is going to be to the negative 4 times negative 1. 2 negatives multiplied give you a positive. And then I am just going to say it's 5 to the negative 1 power. And then when moving day happens, which is our next step, 5 should move exactly where it's supposed to be if it has a negative exponent. So 5 to the negative 1 moves up top. So I should have, well, 3 times 3 times 3 is 27. So I'm just going to put the 27 up top. Since they all had positive exponents, there's no issues with that. The 5 moves to the top now. The question is, what operation happens now between the 27 and the 5? Should be multiplication. Because when dividing here, it moves to the top part, just like we multiplied on that previous example when the 2 x's were on top. That's going to multiply as well. All right, m to the negative 6 is going to move to the bottom and become m to the positive 6. N to the negative 3 is going to move to the top and become n to the positive 3. And then our n to the 15, it's chilling on top, it stays there. Our m to the 4, it's chilling on the bottom, it stays there. If you're positive, don't move it. If it's negative, move it. All right, so you take 27 times 5, which is about, I think it's 135. That remains on top. If these are in the same spot, remember you add the exponents because we're multiplying these 2 parts, so it's n to the 18. And then on the bottom you have m to the 6 times n to the 4. That's m to the 10. So our final answer is right there. All right, let's check out some more. Number 11 is different. I'll rewrite it larger so everybody can see this better. It's negative 1x to the negative 24. All right, I'll just write it out. This one's different because everybody is inside the same fraction taken to the 3rd power. So you can actually do a lot of different things inside here. If you use the order of operations, it's actually interesting. You can do simplification inside the parentheses because parentheses comes before exponents in the order of operations. However, You technically can also distribute the 3 to all the parts too. It's one of those weird situations where you're allowed to do both the things inside parentheses or distribute that exponent to all the parts. I'm going to show you guys how to simplify the inside of the parentheses first. So if we say, ignore the 3 for a second and say, I'm trying to work inside the parentheses. Parentheses come first when we're doing the order of operations. Well, I can just check out the ones with negative exponents, like the negative 24 power, the negative 2 power, the negative 14 power, and the negative 8 power. And I can say, let's move those and simplify first before we apply that 3 on the outside. So the negative 1 stays, the 2 stays, the y stays, and the z stays. Or the z squared stays, because they didn't have negative exponents. X to the 14 moves up top. X to the 24 moves to the bottom. And I've got z to the negative 2 on top, which becomes z to the positive 2 on the bottom. And then y to the negative 8 comes up top. Now this thing is still technically to the third power, so I'm just gonna write to the third power here, just to make sure I'm writing true statements. And now we simplify. So we're going to have z to the 4 on the bottom. You're going to have y to the, remember there's a little 1 there for this one. It's going to be y to the 9 on top. And then opposite subtract here. You've got 14 minus 24. But maybe a better rule to go by is just ask yourself, who's the bigger exponent when they're both positive? 24. All right, subtract 24 and 14. You get 10. That means that wherever the biggest power lay, so wherever the biggest power lies, that's where the final answer is going to be. So it's going to be x to the 10 on the bottom, because 24 minus 14 is 10. Bigger power is on the bottom. That means you're going to have a positive exponent on the bottom. All right, and then you got negative a half. Great. Oh, it was still taken to the third power. So now, I know this is kind of a lengthy multi-step one, but as you can see, we're pretty much doing the same thing on the previous examples we've talked about. Just distribute the 3 to all the parts. So a power to a power means multiply the 2 exponents. So you're going to get y to the 27th on top. Let's see, can we see that? Yeah. And then you've got negative 1 to the third power, which just means it's negative 1 times negative 1 times negative 1. And then that 3 goes to the bottom as well, because the entire fraction is taken to the third power. So it's z to the 4 times 3. 4 times 3 is 12. X to the 10 times 3, which is x to the 30. And then you've got 2 to the third power, or 2 times 2 times 2 on the bottom. Which you could probably just simplify this as negative 1 times negative 1 times negative 1 is negative 1 in one step. And then 2 times 2 times 2 is 8. All right, so it's negative 1, y to the 27, over 8, x to the 30, z to the 12. All right, I'm going to ask you guys to try this example on your own, and then after I rewrite this larger, I want you to pause the video. All right, so pause. Try it on your own. Okay. Let's see what you guys came up with. Since these two are separated by different powers, it's basically like the negative 3 is only being applied to that top part. This 2 is only being applied to this bottom part. So we can't do the thing where we simplify the insides of the parentheses first because they're 2 separate entities. That means we have to distribute this -3. And we have to distribute this 2 to all the parts. Oh boy. Let's try that again. Is this an N? Yeah. Okay. So for the top, you're going to get n to the 2 times -3, that's -6. M to the 3 times -3, -9. Okay, once again, we've got a negative exponent with a coefficient. We have to be very careful here. I'm just going to rewrite this as -2 to the 1 times -3. It's -2 to the -3 power. I'm also going to put parentheses around it because, I mean, if you've ever tried working with a calculator, a lot of times these parentheses, when they're not used around negatives, bad stuff happens. All right, on the bottom, you're just multiplying a +2 through, so you're going to get n to the -8, m to the -24, and 4 to the 2 power. All right, it's a moving day for all the negative exponents. So you're going to move, and 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 you're going to move. So basically, everybody's flipped, except the 4 squared remains solid on the bottom. So 4 squared is 16. I'm just going to replace that with 16. If you guys are okay with that. So you got 16 on the bottom here. Now, everybody who was on top is moved to the bottom. So that -2 is now on the bottom, but to a positive exponent of 3. I'm just going to use black marker because I don't think the red's showing up very well. So it's -2 to the +3 now. Okay, so check that one off the list. M to the +9's on the bottom now. N to the +6 on the bottom. M to the +24 on top. And N to the +8 on top. All right, let's simplify this thing. Opposite sides, they subtract. So we're going to have an n to the 8 minus 6 is n to the 2. You know, I'm going to keep with the black markers because they're showing up really nice on the video. You got n squared. Since the bigger power's on top, our final answer is going to be on top. M to the 24 over M to the 9. Subtract those two. Bigger power is on top. 24 minus 9 is 15. And then you got a bunch going on the bottom. This is 16 times -2 times -2 times -2. That's what -2 to the third power really means. So 2 to the third power is 8. If there's an odd number of negatives, it means that 8's going to be negative. So it's technically 16 times -8. Which 8 times 8 is 64, times 2 with the 16. So it should just be double 64. You can check these with a calculator, of course. But double 64 is 128 on the bottom. Now, it's still negative. And that does not mean we're going to move it to the top just because the coefficient's negative. You only move negative exponents, powers with negative exponents. This has a positive exponent of 1. It's negative 128 to the first power. All right, there are 2 more examples attached to these notes. I think what I'll do is I'll work those out on pen and paper, scan it, put it into Google Classroom. You guys check that out. And I'll post what problems that you guys should be working on over the next couple days. Hopefully, again, you guys are not going stir crazy with this, shelter in place. Continue to be safe, and email me any questions you have. Or if I made weird mistakes on this video, or if I'm blocking the work that you should be seeing, just email me those, and I'll try to adjust as best I can. All right, see you guys.